Okay, so let's think about balancing chemical equations. So this is where we know a reaction has happened. We know that at some level, these atoms and ions have been rearranged into different stuff. So we have different products on the other side. Now, something we have to keep in mind is the law of conservation. If I have potassium on one side, I need to have potassium on the other side. If I have two potassiums on one side, I have to have two potassiums on the other side. So I have to represent the same number of elements on one side as I do the other. So the same number of atoms. So this has to happen through a chemical reaction. If there's no reaction, then I don't have to worry about balancing it. So let's think about this just like making a sandwich. So let's say I got some bread and I have some peanut butter. So my ingredients are just bread and peanut butter. Now, the formula for a peanut butter sandwich is 2 slices of bread and a scoop of peanut butter. So, right now, if we're looking at this, this is not applying to the law of conservation of mass. It does not subscribe to it. It's not fitting in with our definition because I have 2 pieces of bread over here, but I only have one on this side. So, what I'm going to do is I'm actually going to change the equation by adding this thing called the coefficient out front. Now it does. I have 2 pieces of bread, 1 scoop of peanut butter. Even though they're now a new formula, they're combined, they've undergone a chemical reaction. Hypothetically, they don't actually undergo a chemical reaction. But I still have 2 pieces of bread and 1 scoop of peanut butter. So I think it'd be helpful if we think about these terms, so these new words that I'm using here. Reactants are just the things that go into my reaction, right? So these are the things that I'm talking about at the beginning. And then the products are what comes out on the other side. It's the stuff after the reaction has happened. And we show that a reaction has happened by using this arrow. It's called a reaction arrow, but it's just showing the direction of the reaction. And it's also pointing to where the products are, okay? So these are our element symbols and these are our subscripts. These are things that we've used before to talk about different compounds. But we have these new things called coefficients. These are the numbers out in front. And we arrange those numbers differently. So I can add 2 here or 3 here as long as it conforms to the law of conservation of mass. I have to make sure that I'm ending with the same amount of stuff on either side of my equation. So once that formula has been written, so once the equations are set, so CH4 plus O2 plus CO2, the only thing that I can change is the coefficients. So I want you to think about this like a game. I want you to think about it in terms of rules, but I want you to think of this almost like Sudoku, right? It's a puzzle. So you can change the coefficients only. You have to have the same element symbols on each side. If I have K on one side, K's got to be on the other side. And you have to have the same amount for each type of atoms, right? So I have to have the same amount. If I have 5 potassiums, I need 5 potassiums. And here are some tips. We're going to balance compounds first. We're going to save the things that are just one thing by themselves for last. And I'm only going to balance one thing at a time. Right? If I'm balancing oxygen, I'm going to balance oxygen on the other side. If O and H, if they're in the same place, save them for last. Polyatomic ions stay together. Remember, they're ions. They stay together. Those are stuck together and I'm not going to break them apart. And then water can be changed if we need to HOH to help kind of see the relationships a little bit more because OH, if you remember, is also a polyatomic ion. So if you see OH on one side, it might be easier to break that apart just a little bit. All right, so let's take a quick peek at some balancing equations. Let's balance a few to see what's going on. So I'm going to start with making this. I'm going to make a little scorecard here to see what's on each side. So I have Cu over here, I have Al over here, and I have Cl over here. So I'm just listing the different elements on one side and the other. So a before and after. So right now I have one aluminum over here, and I have one aluminum over here. Looking through here, I have one copper, right? There's no subscript, so I have one copper. Looking over here, I have one copper. So far, so good. And then we have chlorine. Chlorine has this little subscript here. That's a 2. And then over here, chlorine has a 3. So this is not balanced. It's not applying to the law of conservation of mass. This is saying that this chlorine appeared out of nowhere. So we got to balance these. So let's look at it. What number do these both go into? So if I have groups of these things, that I can have the same amount of chlorine on either side. Well, if I have 3 over here and 2 here, right? Because that will give us 6 for each. Chlorine is going to change to 6. And because I changed this coefficient out front, aluminum now is also 2. And then over here, the chlorine went to 6. And copper went to 3. So we're still not balanced. We're not done yet. Because copper has 3 of them. Copper only has 1 over here. So this needs a 3. And then aluminum has a 2. This only has 1. So this needs a 2. Okay. So we're just playing. We're changing the numbers in the scorecard a little bit so that we can order them. Now, what you want to do when you're done is just check. I have 2 aluminums over here. Yep. I have 2 aluminums over here. Yep. I have 3 coppers over here. I have 3 coppers over here. Those are good. Chlorine, I have 6. Chlorine, I have 6. Chlorine, I have 6. Chlorine, I have 6. And these match, and these match, right? And that's the important part. So let's take another look at magnesium, and this is hydrochloric acid. So let's take a look at those two together. So let's do our scorecard. We got Mg, we got H, and we have Cl. And over here we should have Mg, we have H, and we have Cl. So we're just trying to look at how we can balance these two out. So at the start, over on this side, I just have one of everything. There's no subscripts and there's no coefficients out. Over here, I have 1 magnesium. Hydrogen's diatomic, so it has a 2. And chlorine, that has a 2 as well. That's part of this compound here, so that's a 2. So we just have to mix things around. So let's pick our compound and let's fix our compound. So I need 2 chlorines, 2 chlorines. So if I make this into a 2, I got to change these. Hydrogen then becomes 2. Chlorine becomes 2, right? Because I got the 2 up front, so that's 2 groups of these, right? So we're going to pull down and see what we got. So 1 magnesium, 1 magnesium, 1 hydrogen. 2 hydrogens, sorry. 2 hydrogens, 2 chlorines, 2 chlorines. We're done. That's a nice and easy one, right? Now let's take one that takes a little bit more work and effort because there's more stuff going on. So let's see over here. We got Fe, so we got some iron, we got some chlorine, we got some sodium, and we also have PO4. I'm going to keep that whole thing together because it's a polyatomic ion. So over here I got, let's keep them in order here. So let's do Fe, we got Cl, we got Na, and we got PO4 3 minus. So again, we're going to try to just keep these scorecards. So Fe is 1. Cl is 2, Na is 3 here, and then we have one of these PO4 groups. Over here I have 1 Na, I have 1 Cl, I have 3 of these irons, and I have 2 of these PO4s. So we have a lot of things going on. Now the easiest one to balance is this one, the NaCl. Because they're both singular, I can just save that one for last. I need to make sure that all these other things balance first. So just as a tip and just making sure, I'm going to take the more complex thing and I'm going to actually start there. So at the very least, I have 2 of these PO4s here and I only have 1 here. So I'm just going to put a 2 on this side. I'm going to start there because I know that for every one of these, I at least need 2 of these. Okay. So let's rearrange. So now my sodium has 6, right? And my PO4 now has 2. So 2 times 3, that's going to give me 6 of those sodiums. 2 times this PO4, I'm going to have 2 of those as well. Okay. So now we're going to do our check over here. We got the same. I haven't changed anything on this side. I changed on this side, and I've already adjusted those. So now let's look at the next part. So next part of this one is a 3. And I have 1 Fe over here, so I have 3 irons, 1 iron. So let's put a 3 on this, and let's readjust. So we're only changing things on this side. So my iron is 3, and 2 times 3 is 6, so I have 6 CLs. So here we are. So my new counts are 3 irons, 6 chlorines, 6 sodiums, and 2 PO4s. So the irons are good. The PO4s are good. The only thing left are 6 NAs and 6 CLs, which this is singular, remember? So now we just need that 6, and that will be nice and balanced. So again, all I'm really doing is just changing these coefficients, these numbers out front, and I'm adjusting my scorecard to make sure that I have the right counts of things. I have the same number of things over here on my reactant side as I do on my product side. So same number of irons, same number of irons. If I add all these together too, let's see, this is 6 plus 6 is 12. 12 plus another 5, that's 17. Over here, we've got to change these, but here they are. So I have 12 and 17. So I have 17 atoms on either side. So this is 100% balanced. I know it. I'm sure of it. I can count on it. So that's what I want you guys to practice. I want you to practice taking some of these equations and balancing them out. All right, we'll talk to you soon.